Hey, what's up guys? My name is Cherno and welcome back to my OpenGL series. So this is really the first episode of my OpenGL series. Last time we just talked about what OpenGL actually was, a little bit about how it worked, and also what this series would actually contain. If you guys haven't seen that video, then check it out in that corner. Today though, we're actually going to jump in and write some code. We're going to get some work done, we're going to get an OpenGL window displaying, and maybe even draw a triangle. With this series specifically, I want to take a more practical approach. With the C++ series, I did a lot of kind of explaining, a lot of theory before we actually started writing code. I still want to do that for this series because I believe it's very important to understand actually how everything works. But with these kind of first few episodes, I just want to get some code done. I just want to actually write some code and have something happening on the screen so that hopefully you guys can kind of feel that sense of progression a little bit better. And then what we'll actually do is end up kind of as that goes on, maybe once a week or so, have a bit of a theory video and just talk about how OpenGL specifically works or what actually happens behind the scenes. Now with that being said, our goal for today is going to be just to create a window, right? I want to be able to have my operating system create a window for me so that my application is actually in the form of a window. And then hopefully the goal with that is that in the future we can draw all of our graphics inside that window. Now this series specifically, I want to have multi-platform support, right? I want people who are writing this code on Windows, Mac, and Linux to also be able to run this code, and it should work on all three platforms. What that means though is that we need some way to set up windowing, and windowing, or in other words creating windows, is very, very platform specific. So in other words, the way that you create a window on Windows is you use the Win32 API, right? So you actually use the Windows API to say, hey, I want a window, because of course the way that you create a window is going to be specific to the operating system you're using, because that's like an operating system level thing. And that's what I probably would do if I was writing a game engine. I would probably just take the time to actually set up a window myself using the actual operating system's API for each platform that I actually want to support. This series though is not about how to write a game engine. That's going to be another series later on. This series is specifically about OpenGL and how OpenGL works and how to write OpenGL code. So we don't really care about how to set up a window and all that. We just want to write some OpenGL code. And so because of that, I'm actually going to use a library that will basically do that for me. And all this library is going to do is provide me with the appropriate platform layer. So in other words, it's going to provide me with an implementation of that windowing creation code and management code as well for Windows, Mac, and Linux so that everyone can follow along with that. And there are several libraries that allow us to do this. But the one that we're going to use is something called GLFW. And the reason that I like GLFW is because it's a really kind of lightweight library. All it's going to do for us is create a window, create an OpenGL context, and give us access to some basic things like input. That's all that it's going to do. It's not like STL, which is like a full kind of, they've actually got like a renderer there so that you can draw squares or triangles or whatever you want to the screen, and that'll be implemented in either DirectX or OpenGL, and that's like a whole kind of framework. I don't want any of that. We're going to be writing our own stuff. All I want to do is automate that first step of I want to create a window, and I don't want to have to write different implementations for each platform. I want this code to be pretty multi-platform, pretty portable, so I'm going to use a library like GLFW to just speed that up for me. Again, I could write it myself, but that would mean writing it 3 times for each platform, Windows, Mac, and Linux in this case, and that's just going to be a waste of time and not really the point of this series. So just want everyone to understand why I'm actually doing this. So yeah, let's go ahead and download GLFW. If you go to the URL that is in the description below, which is glfw.org, you'll be taken to this page. We care about basically 2 pages here. First of all, there's just download GLFW 3.2.1. It's exactly what we want, but also under documentation, there's actually some example code of how to create a window in GLFW. And you can see that it's very, very concise, right? All we have to do is basically initialize GLFW, and then we can just create our window, and that's it. It's as simple as that. If we want to make an OpenGL context, we just call this one function, and then we can start a basic loop to poll for events and make sure that when our window is closed, it actually closes. And you can see we can write OpenGL code right over here. It's very, very simple, and it's pretty much exactly what we need to get started. So up the top here, I'm going to go back to GLFW. So this download is actually for all of the source code. This is another thing that I want to mention. If this was a game engine series or something and I was actually making a serious application, I would probably download the source code and build it myself. I would add it as a separate project in Visual Studio and probably compile it into a static library and then link it with my main application, just so that if I need to debug something, I have the source code right there, and there's really no downside to do that. I like having as much source code as I can in my project. However, this again is about OpenGL. We don't want to waste time with that. All I'm going to do is just get pre-built binaries for my platform and just build with that, right? So to do that, I'm going to go to download, and then you can see we have Windows pre-compiled binaries. So Windows actually has pre-built binaries. Linux and Mac, it says that you actually have to download and compile the source package above. There's a guide, so follow that if you're on one of those platforms. I suspect people will probably run into problems with that because it's not the most trivial task, and with like make systems like that, it just tends to be all over the place. So if you need help with compiling this for Mac or Linux, definitely join my Discord at thecherno.com/discord. There'll be plenty of people there who will be happy to help you out with that specifically. But since we're on Windows, and we will be for the entirety of this series, I'm just going to download the appropriate binaries. Another note here, we have 32-bit or 64-bit binaries. Question I get all the time, which one do I get, right? A lot of people seem to think that, well, I'm running 64-bit Windows, so of course I want 64-bit Windows binaries. That's not correct. What you actually want, the architecture that matters is the architecture that you're building for, right? If we set up our Visual Studio project to build for Win32 or x86, then we want to get the 32-bit ones. If our application is being built for 64-bit or x64, right, that's where we want the binary. So it's actually what matters is the architecture, the platform of your application. So how you compile your application, not the operating system you're using. Of course, a 64-bit application won't work on a 32-bit operating system, but if you're on a 64-bit operating system like Windows 10 64-bit, you can run either 32-bit applications or 64-bit applications. So the one that you actually download is going to depend on what you compile your application with. So we'll just be using a 32-bit application because we don't need a 64-bit one. For more serious projects, I'd probably use 64-bit. There's no real difference. It's easy to switch as well. It's not like a whole deal. It's not like we have to write different code or anything most of the time. It's pretty much the same thing, but to keep it simple, we're just going to use 32-bit. So over here, I'm going to click on 32-bit Windows binaries and download that. Okay, so inside the archive that you download, there'll be a GLFW folder and a bunch of libs. We'll talk about setting all of that up in a minute, but first we actually need to create a Visual Studio solution. So over here, I've got Visual Studio Community 2017. I'm going to click File, New, and then Project. I'm going to make sure that I'm under Visual C++ and General and select Empty Project as my template. We're just going to make a brand new project from scratch. In the location, I'm actually going to change the location from being in my documents to basically being C, Dev, YouTube, and OpenGL. You can set this to anything else. I like to keep all of my development kind of stuff under C, Dev. That way it's not in a user folder and I don't have to deal with all of that. So just C, Dev, and then OpenGL or whatever. I've just put it into a YouTube folder because, of course, this is for the YouTube series. I'm going to call this OpenGL and just click OK. Okay, so we've got a Visual Studio solution and project set up. Everything looks pretty good. If you want to set it up properly and more or less just set it up in a nicer way, because the default Visual Studio way that it sets up new projects and solutions is a bit weird. Check out my video on my kind of favorite setup for Visual Studio for C++, so there'll be a link up there. I'm not going to go through all that right now because it's just going to take time and it's not really that necessary, but definitely check out that video if you want to know how I would set this up properly. So again, all we're doing today is we're trying to set up GLFW basically as quickly as possible. So under source files, well, one thing I'll actually do is I'll click on the project name, I'll click on show all files, and then I'm going to actually make a new folder here called src for source. So this show all files mode actually will mimic our Windows Explorer file structure and directory structure and all of that. Again, that's all described in the video that I linked up there, so check that out if you're not sure. Under there, I'm going to add a new item. I'm going to call this application.cpp. This is going to be our main file, the file with the main function. I'll hit add, and I finally just have a normal C++ file in my project. What I'm going to do now is just basically include iostream, make sure everything's set up. In main, I'm going to type in stdc out hello, and stdc in.get. I like to do this just to make sure everything's set up and everything will compile. You can see we get this opening with hello, which is perfect. So now I'm ready to actually link GLFW and get it to work. If I go back to the GLFW website here under documentation, literally all I'm going to do here is just copy pretty much this source code just in its entirety, copy, and just paste it over here, okay? We're gonna get a bunch of things not working because of course we need to actually set up the library. So let's talk about how we're gonna set up GLFW in our project. I'm going to go to that zip archive that I downloaded with all of our libs. There are two things that matter for us here. Every kind of C++ library has include and also lib, right? So we're going to talk more in depth about how C++ libraries work and how to link them and all the differences between all that in a future video in the C++ series. It'll be linked up there if it's already made, but definitely check that out if you're not sure about how kind of libraries work in C++. But out of here, what we care about is the lib file. There's actually two here. The two lib files that we have here, you can see one's labeled with DLL. So this one's used for dynamic linking if you want to use the DLL to link at runtime. GLFW3.lib is the one that we're going to use though, because that's just for static linking. We don't want to link GLFW GLFW dynamically. We don't want to have to use a DLL file. There's no reason for us not to static link it, so we're going to link it statically. So what I'm going to do is under OpenGL, I'm just going to right click on there, hit open folder in File Explorer so that we actually get to our location of all of this. And what I like to do is in the solution directory, so this is the solution directory, the directory with that solution file, I'm going to make a new folder called dependencies. And inside dependencies, I'm going to make a folder called GLFW. And then inside here, I'm actually going to put all the files that I want. So out of what I want in this actual archive that I downloaded, I want include and I want libvc 2015, which is the latest Visual Studio version that we have here. We'll paste this into here. Of course, we're actually using Visual Studio 2017, although it won't matter for our purposes. It will still work. Inside here, I can actually delete that DLL file and the DLL lib as well. We don't need that, and include should just have everything we need. So now what we actually need to do is tell this project that I want you to also include this folder for includes so that we can write code such as include glfw/glfw3.h, right? So we need to add an include directory. And then we also need to add this lib file to the linker so that the linker actually links this lib file in and it can match up all of the GLFW functions. So let's take a look at how we might set that up. What I'm going to do is right click on OpenGL, hit properties. Now the most important thing here, let me just make this smaller. The most important thing here is that you're on all configurations, okay? And all platforms doesn't really matter. We're just gonna stick with Win32 for now, but all configurations, make sure you're on all configurations and not like release. If you're editing release and you're actually in debug, it's not gonna affect your currently selected configuration and you'll get errors. So we want all configurations. Under C, C++, in general, we're going to add an include directory. Now, what we could do, right, is open up our folder here and just basically copy this path and put it in there. Now, we don't want to do that though, because other people who will use this project might not be storing it in C, Dev, YouTube, OpenGL, blah, blah, blah. We actually want to make it relative to the project itself. And specifically, I like making it relative to the solution directory. Now, Visual Studio has a macro for us that is actually our current solution directory. And if we open this tab here and go to macros, then you can actually type in solution directory and you'll see what it actually is. It's cdev YouTube OpenGL/OpenGL. So basically what it is the actual solution directory that we have here, the directory that has this solution file. And we're actually going to base our include directory path from that solution directory. So I'm going to type in solution directory. That actually already has a backslash at the end, a trailing backslash. So next we'll go into dependencies, GLFW, and include. In fact, all I'm going to do is copy that last part and put it over here, okay? That is our include directory. If you want to make sure it's correct, you can go to edit here and look at the evaluated value. If you copy that into your file explorer and hit enter, it should take you to, well, GLFW. And of course, now that you've set that up, over here, this include glfw/glfw3.h should work because we start in this include directory, we go into the GLFW folder, and there's glfw3.h. Okay, so that's how we can set up the include directory. Next, I'm going to set up my library directory as well. So under linker in general, I'm going to specify an additional library directory. This is going to be very similar to what we had before. It's going to start off with solution directory. Then it's going to go to dependencies. In fact, I'm just going to go back to my folder and copy the path. So under GLFW, we have libvc 2015, and there it is, right? So I'll grab that, chuck that in here, and we're good to go. Under input, I'm actually going to specify which file we want to link. Now, we don't actually need to link all of these. I don't know why they're here. They're here kind of by default, but they're actually included in the default library, so we can get rid of all that to keep it nice and clean, and just type in glfw3.lib. So basically, we're linking with this glfw3.lib file. Again, if I'm going too fast or anything, I will make a video specifically about this in more detail. I just don't want to spend all day on this. So check that out, check that video out if it's already made. If it's not, then just wait. Now, another thing we actually have to link with is OpenGL, but we'll deal with that in a minute. I'm just going to hit OK because that's all we'll need for now. You can see that all of our compilers go away. If we hit Control F7 to actually compile our application, you can see it compiles successfully. Now, it's not going to link successfully because we haven't actually, you can see we're using an OpenGL function here, but we haven't linked with OpenGL. But the compilation succeeds, and that's kind of all we care about for now. Now, if I right-click build this, it's actually going to compile and link the entire application. So let's take a look at that. Okay, so we get a few things. First of all, we have an unresolved external symbol. Again, I'm not a big fan of looking at the actual error list. You should be looking at the output because the error list is just mostly lies. Well, not in this case, but it can be. And this always gives you more detail. Okay, this kind of default lib conflict, don't worry about that. That's just a warning, and specifically it's an annoying warning that we don't need to think about fixing even. It's not that important. This is important, however. We have GLClear is an unresolved external. We also have a bunch of Windows stuff that is unresolved now because I did actually delete most of the libraries that we linked against, so we'll bring some of them back in a minute. But the first one that we're getting, which we'll fix first, is GLClear, okay? And we can actually get rid of that error by linking with the OpenGL library. So what's happening is we're getting a linking error. If you guys don't know how the C++ linker works, check out that video because I have already made that. But basically what the linker is trying to do now is find a definition for that GLClear function. That GLClear function definition is inside an OpenGL library file, so we actually have to link against that. So over here in additional dependencies, I'm just going to add a semicolon and type in OpenGL32.lib. If I hit OK and I build this, you can see that that first error should go away. And in fact, now the first unresolved external symbol is just registered device notification stuff, which is basically Windows kind of API stuff. So let's go ahead and add that in. Now, before we do that, I actually want to show you one way that you can find these things. I've deliberately gotten rid of all the kind of Windows includes because I wanted to show you guys how this actually works and how to set it up kind of really from scratch. But if you see errors like this, because they actually do tend to be quite common sometimes if you're not set up correctly, you can see that the function name is actually registered device notification W. So let's grab that and copy that and actually Google that. So on MSDN, I'm just going to Google that. You can see we're actually created with MSDN here, which is the Microsoft documentation. So this is the actual function that we're trying to link, and we don't know where it is. So if we scroll down, you can actually see that the library that it's in is user32.lib. So what we can do is copy that and actually link with that, and that will actually go away. So over here, I'll just type in user32.lib, hit enter, hit OK, and try and build this again. You can see that we get way less errors now. We've only got just a handful now. And a few of them are basically create device context here and swap buffers and all that stuff. So again, I want to do the same thing with this. I'm going to copy this. I'm going to go over here to Google, just basically Google that function, click on the MSDN link, scroll down, and you can see this one is in GDI32.lib. So back to my project, and I'm going to link against GDI32.lib. Okay, I'll hit OK and try and compile my code again. All right, just a few more now. Drag query file W, again, copy that, paste it in here, MSDN, and here it is, shell32.lib. So back over here, you guys kind of get the drift. Shell32.lib, okay, and build. All right, awesome, no errors at all. And if we hit F5 or just local Windows debugger to run our actual application, you can see that we get a black screen. Now, all this manual linking that I've just done, you don't need to do that yourself. When you create a new empty project in Visual Studio like we did, you can see it actually did have a bunch of links already, including like kernel 32.lib and stuff like that. I just wanted to get rid of them just to show you how it actually works and how to link everything kind of from scratch. You don't need to do that though, this was just kind of as an example. Now we got a black screen here, let's quickly draw a triangle. Now what I'm actually going to do to draw this triangle is use legacy OpenGL. So in the first video we talked about what legacy OpenGL was and why we shouldn't be using this. Legacy OpenGL is the fastest way that I can now, in like 5 lines of code, draw a triangle on the screen. And my purpose right now is just making sure that OpenGL is up and running, not writing again. I'm not writing a graphics engine right now, right? So whilst you shouldn't be using legacy OpenGL, like in, I guess, professional applications, it's perfectly fine for debugging. People need to realize that even though some things are discouraged, if you're just writing it temporarily to test something, there's absolutely nothing wrong with it. So just keep that in mind. So what we're going to do over here under GLClear is I'm actually just going to type in GLBegin, GL triangles, and you guys will kind of get it to experience some legacy OpenGL code. So between GLBegin and GLEnd, we just want to specify 3 vertices. I'm going to type in GLVertex2f, which is going to specify a 2-component kind of vertex, or 2D, I guess, vertex. Now, by default, our projection matrix in OpenGL is between -1 and 1 in every dimension, in every axis. We'll talk more about projection matrices and all this fun stuff in future videos. Again, just trying to draw a triangle now. So I'm going to type in -0.5f and then -0.5f for y as well. And then for my other ones, I'm going to maybe make this one in the middle. So it's going to be just 0f for x and also +0.5f for y. And then this one's going to be +0.5 for x and -0.5 for y. So I should be drawing a triangle that is basically in this shape. Let's hit F5. And you can see that I get a triangle that's perfectly kind of in the middle of my screen and looks pretty good. Okay, so we can now conclude that OpenGL is working. And that's gonna wrap up this video. We've basically accomplished everything we wanted to. We've got an OpenGL window. Everything right now is in our application file. We are probably going to move it just into a class or something just to keep it a bit more simple. We'll do that next time. But overall, again, we're not going to spend too much time creating an API for ourselves because we want to learn OpenGL. So we've got something up and running. You guys can recreate this code on your computer and hopefully get something as well. So you can finally making nice little cute OpenGL application which draws a single triangle. Exciting stuff, I know. But as we go on, we'll kind of deal with more stuff. Now, for all of the code in this series, I do actually encourage that you copy it down yourselves, because when you actually copy code, even though you are just copying from a screen, you actually learn it because you're typing it out yourself. It's like when you meet someone new. A lot of the times you'll meet someone new, they'll introduce themselves and say their name, and then you'll just forget their name straight away. But if you actually say their name back to them, like, hello, Bob, then you're way more likely to remember their name, right? So kind of with this as well, I like the idea of people actually copying code down themselves and actually physically typing it themselves, because once you do that, muscle memory will kind of kick in and you'll actually learn a lot faster. That being said, if you really want the source code, I am actually making that available to patrons. So if you pledge on the cherno.com/Patreon, or sorry, if you pledge on patreon.com/the Cherno, probably make the cherno.com/Patreon work as well. But if you go to patreon.com/the Cherno and you pledge there and you help support this series, you will actually get access to the code on GitHub, and that will be separate for each episode as well, just like it is for all of my other series. So if you really want the source code and you really want to help support the series, it's just basically you just get a reward for helping to support this series and making sure that I can make more videos. There's also a bunch of other rewards on patreon.com/the Cherno. So I really appreciate all the help I get from there, and that's what basically lets me sit down and make these videos properly. So much appreciated. Anyway, next time we're going to abstract this out into a class and actually talk about modern OpenGL, because what we've done right now is we've created an OpenGL context and a window and everything, but we're actually only limited to using OpenGL 1.1, which is what ships with Windows. Windows has its own rendering API, DirectX, Direct3D, so they don't actually provide you with all the functions you need for modern OpenGL. As I mentioned in the Welcome to OpenGL video, that's provided for us by our GPU drivers. So what we need to do next time is actually somehow get all of those functions that are in newer versions of OpenGL out from our GPU drivers, so that we can actually, we want to be able to call the functions, right? So that's what we need to do, and that's what we'll talk about next time, as well as probably moving this out into a class and all of that fun stuff. And then that's when the real fun's going to begin next time. So I'll see you guys in the next video. Goodbye.